All right, so just to wrap up the day, I realize it's late and it's been a long day. I want to thank everybody for coming. I thought I'd just say a few words about things we didn't get a chance to talk about today. First thing I want to emphasize is that we really want people who are trying out the programming system to give us feedback. And much of what you see here today is based on the feedback and experience from the last year and things people told us that they didn't like and that they wanted to see improved. And so we really appreciate the critical input. It's not a bother for us at all if there are things you don't like and you tell us about those. So other things that are in progress that we didn't have a chance to talk about, I'm just going to very quickly go through some of these things. Okay? So resilience. It says if a task fails, actually Legion has enough information in the task graph to restart it. So in principle, if something fails, we can tear out that portion of the task graph, relaunch the tasks someplace else if it was a node or a memory that died. And actually, we've been making progress towards this. So step one is a new versioning high-level runtime where actually the version numbers of regions and what data is the most current data is much more carefully tracked than what we were doing before. Mike finished that a couple of months ago. That's completely done. And it's a basis for a bunch of other things, but as a nice side effect, it's faster and a little bit easier to maintain than what we had previously. We've been working on making the system more extensible to new kinds of devices, where device is a nominal notion. It means it's not meant to be just hardware devices. This is already done. And so it's now possible to extend the low-level runtime with a new kind of processor, for example. So this is how we'll support nice landing. It's also how we'll eventually support things like OpenMP, interoperation with OpenMP by having a special OpenMP interface that we can launch OpenMP tasks on some resources that are dedicated to OpenMP. I mean, there's just a standard interface now for adding new kinds of things to low-level runtime that we can then target. And we would love help if people want to do ports of things, because we have limited capacity ourselves to do them all. For visualization, we heard some about that today. So various people have been playing with this, including us within the group. So some of the pieces here that we need to do visualization is in situ analysis. We need to be able to handle external data formats and integration with visualization tools. And we've done some examples of this with S3D. And we're planning to add OpenGL support so that we can actually drive visualization devices and do this in real time. And that'll be through another kind of OpenGL processor that's done through an extension of the low-level runtime. So we can launch OpenGL tasks that will do the visualization for us on some screen. Disk support. So being able to use disk as scratch memory and out-of-core algorithms, and just being able to have very, very large regions that are manifested on disk. That's already done as part, really, of the system to support external resources that Jihao talked about, but you can use that today. If you want to be able to do out-of-core algorithms, you can just have regions that live on disk, and the system will treat them like any other kind of memory and overlap the communication, data movement with the computation. There's a new DMA subsystem that is very much in progress. And this is a very, very important part of what Legion helps you with and does well. And so generally speaking, custom DMA strategies are much better than generic ones. And we've, up to now, been writing special purpose DMA code for the important cases. But we want something that's more general. And so we're redoing that, and like a lot of other things. We've had some experience, and we're going to do something better. And this is very much in progress, but should be, it's already working, but we haven't really told people about it or encouraged people to use it yet. So this is something that will become available shortly. All right. JIT support. So JITting is useful if you have special cases. That'll be much faster than the general case. And if you're going to use those special cases lots and lots of times. All right, so you'd like to have custom code if you're going to use that code a lot. And some examples where we think this would be desirable is DSL clients, where some of the runtime information would influence the desired code, so that DSL may know that we can specialize a particular operation and might want many variants of that operation. And just another example is DMAs. So there's lots and lots of examples where The combination of data layout and what memory you're moving from. And two, I mean, there's a huge space of potentially customized DMA operations. And by adding JIT support through the Regent interface, the Terra Lua framework, we will then be able to crank these things out in a much more convenient way than what we're doing now. So the plan is to be able to not only JIT compile stuff from within the Regent framework, but also to register that code as new runtime operations that can be invoked inside the runtime, and be able to do that dynamically. And LLVM IR will be the first supported input language, although not necessarily the only one. All right. And finally, we talked a lot about this today. It came up multiple times. I think at least half the talks mentioned this. So index-based launches, the efficiency of this operation is really critical. And again, the trade-off is that the overhead is always going to be somewhat proportional to the number of tasks you're launching, and inversely proportional to how long those tasks run. So if you're launching an awful lot of tasks and they run for a very short time, the runtime overhead of that is not going to be favorable to the amount of compute that you're doing. And so we have one solution now, which is basically to make your tasks very long running by doing SBM style programming. And then that forces you to then manage, the cost of that is that you're then going to be managing the communication between the tasks, where you normally would have had many smaller tasks that would all return. Now you do explicit exchanges between those long-running tasks. And we're making a lot of investment at the moment in more automatic solutions that we've already discussed. And the bonus is that that'll probably be easier, and we think it's going to be higher performance. So we think it'll actually be faster than the manual versions that we do. All right, the rest. What else do we have? There's a lot of other stuff that we could talk about, and so I'm just going to cram it all onto one slide. So going forward, the plan is to support both Realm and the Legion C++ API, and to have all the optimizations and features on both sides. Okay, so the Legion C++ API is always going to be a dynamic C++ library, and I think that's going to be easier for some people to adopt who don't want all the stuff that comes with Regent. If you're willing to adopt the stuff that comes with Regent, then you get the benefits of static compilation and some of the dynamic code generation and metaprogramming that come with that. And so so going forward, I think we're gonna maintain both of those, and it's going to be an interesting system because you will have the compiler which does all its static optimizations, as Elliot said, but then you have the fallback of the dynamic analysis in the Legion runtime. And hopefully this is going to be more robust than most programming systems, where if an optimization fails, you have catastrophic loss of performance, and in a complex system, it's often very hard to figure out why that happened. All right, so hopefully, yes.
You mean Region and Legion or Realm?
I may have said, I meant to be, sorry, that's a typo on the slide. That meant to be Regent and Legion. Yeah, so Realm will certainly be supported as part of Legion. That's the low-level runtime system. Regent is the program. Yeah, we're getting a few too many names here, and that's sorry. Thank you for mentioning that. So currently, there are some discrepancies. It means as new features get implemented, one gets a little bit ahead of the other in some respects, but the goal is to have all features supported in both. Interoperation is a big thing. We didn't talk about it very much today. The ability to interoperate with external data formats is a big step there, but just generally interoperation with things like MPI is something that we recognize as important and will pay attention to. And then we got a lot of backfill, with expected and needed items. I talked a little bit about we've been adding some testing infrastructure, more documentation in the form of manuals and things that people can pick up and read, and then always improving our tools. And finally, we want to support users. So, it's been hugely beneficial to us, both just practically and as a research project in generating ideas, to talk to users and to learn from them, what works and what doesn't. I mean, the work is so much better motivated when the motivation comes from real applications. And this is something that we've really appreciated, and we realize it's not always easy to be on the bleeding edge. And hopefully, as time goes by, the users will retreat from the bleeding edge further and further and further. But it's worked very well for us so far, and so we're very interested in that engagement. Okay, so tomorrow is our programming exercise. We're actually going to try for the first time to do like a hackathon kind of thing. We're going to have a bunch of exercises for people to do. This room will be set up differently. I think there's supposed to be tables, so you can actually put your laptop on the table, and power strips, so you can actually use your machine all day. And so this is all, and later on tonight, you'll get some credentials. This is all going to be done on Amazon EC2, so you'll get your own little 4-node cluster with GPUs and stuff to use for the day. Actually, you'll be sharing it with everybody else, but whenever you run something, you'll have it for your own use. We're going to do the coding in region because it's a lot quicker to ramp up and less typing. And you just need a laptop and a browser. And if you're using IE, well, if you have problems, let us know. Maybe if you have another one, maybe you could bring that. Have that, standing ready to go. Dinner. So dinner's at 6 o'clock. So the way you get there from where we are here, if you all know Palm Drive, it's the main road that leads into campus from University Avenue in Palo Alto. It's the one with all the palm trees on it, that's the name. As you drive down Palm Drive towards Palo Alto, at some point you will pass underneath the train tracks, so you go through an underpass. Okay, if you get there, you've gone too far. Okay, so the restaurant is just before the underpass on the left. So it's just past the turnoff to El Camino, which is at a stoplight, I think. And between that and the underpass on the left-hand side is where MacArthur Park restaurant is located. It's kind of isolated by itself between the main road and the train tracks. Any questions? So I did that faster than 15 minutes, so we're almost back on time, but not quite. So if there are no other questions, it's a good time to stop. We'll see you at dinner, and look forward to seeing you at the exercise tomorrow. Thank you very much.